Hello, my name is Colin Campbell. I'm a research scientist here at Meter Group, and today we're going to be doing a little digging into some water content data that I collected over the last summer. But before we do that, I want to just set the stage for what's actually going on here. This is a field that's planted in spring wheat. It's about 700 meters across, and we've set up 6 measurement sites. And at each one of these sites, we're making several measurements, but the ones we're going to talk about today are just water content. And while we've installed water content sensors at 15, 45, and 65 centimeters, we're just going to focus in on the 65 centimeter water content sensors. These sensors are the Meter Teros 12 sensors, so they also measure electrical conductivity and temperature, and we're going to grab temperature in a minute because that kind of figures into this discussion. So this field was planted in April of 2019, and not a lot interesting goes on here at the 65 centimeter depth through the April, May, and June. But as we get into July, the wheat's reaching maturity, and they essentially are going to cut off the irrigation water here on July 22nd. And so up to July 22nd, there's really not a lot of movement in the water content. We have one of the sites decreasing a little bit, but each line is flat. And what I noticed as I was looking at this particular graph is that after this long period of very flat data, we suddenly have, after about that June 22nd, again when the irrigation was cut off, we start to see some movement in the water content at this depth. Not only is there movement down, but there's a daily movement of the actual water content signals at all but maybe this top light green line. And it made me wonder, well, what's going on? Initially, whenever you see a diurnal movement, one can suspect, it must be caused by temperature. It's been said that every sensor is probably a temperature sensor first and a sensor of whatever we're really interested in second. So that's kind of a funny comment. But in this case, we look up and say, well, what's the temperature doing at that depth? So here's soil temperature at 65 centimeters. And even though there's just a little bobble in the line, these are almost completely flat. We see the seasonal trends in temperature, but really no diurnal temperature cycling. And this scale is also fairly small. So back to our 65 centimeter water content, if it's not temperature that's actually affecting these lines, then what is it? And we've seen this before actually in an experiment that I did years ago. And what happened, this was a non-irrigated wheat field, and we were measuring down at about 150 centimeters. And when the water had been used up in the upper levels of the soil profile, the roots of the wheat plant just simply went down to 150 centimeters and started taking it up. And this is, again, what I'm assuming is happening here, that the wheat has extended its roots down to 65 centimeters. Since it's irrigated wheat, that's not too deep, but wheat doesn't necessarily need to get its roots down super deep. And as it's accessed that water, we're seeing these daily drops in water, but then we're seeing just a slight increase in water, like here on July 28th. We're seeing that water go up slightly. And so how is that happening? We might understand how the water is being taken out of the soil, but why do we see just a little bit of increase in the water content? Not much, but as it does increase a few tenths of a percent. Well, what I imagine is happening in this case is it's not temperature, but actually roots are growing down into this area. They're probably growing around the sensor, and as we change from day to night, we see a release in the elasticity of the water in the xylem, and maybe just a little bit more water down in the roots as the transpiration pull of the day is lessened and essentially stops overnight. The stomates are closed, and we see just a little bit of water coming back into the roots and possibly into the soil. Now, there was a big discussion many years ago about whether this was something they called hydraulic redistribution, where trees could take up water from deep in the soil profile and essentially give it back to plants near the surface. And although it was a great debate, it was never actually proven that this actually happened, that there was actually water being spread from deeper locations to more shallow locations by roots. But what I would say is that there is a diurnal trend that we can sorry, I said hydraulic redistribution. What I meant to say was hydraulic lift. What this is probably hydraulic redistribution, where we just have roots filling with water, and when they filled with water, we see a little bit in the water content sensor. So this was kind of a fun little exercise. We see this going down from close to the time when the water is shut off, all the way down to essentially when the experiment ended. The water was taken up and the plant senesced at this time.